So we're going to look at two examples from the book. First example is where you want to know what the graph of h of x, which is f of x plus 1 minus 3, is like if f of x is the absolute value function. So we start with one of our toolkit functions, absolute value of x, right, which looks like this. So this we have to know by heart or understand how it's obtained. 0, 0 is a pretty important point for that graph because it's a vertex. So when you think about your toolkit functions, think about their like x, y, intercepts, things like this. If the vertex, if there's one, those are all important points that you'll want to follow when you transform that function. So if we want to transform this function, following what h does, h does f of x plus 1 minus 3. So the first thing that acts on x is this part, f of x plus 1. So we're going to graph this. Okay, y equals f of x plus 1. So that's actually absolute value of x plus 1, remembering that f is just the absolute value function. So x plus 1, like where does our vertex go from that? Either remember that f of x plus 1 will do a shift 1 unit to the left. Another way to remember or to understand why that's a shift of 1 to the left is that if I want to have the same y value here that I have for my vertex here, which is 0, what would be my x value? My x value would need to be minus 1, right? So that I can generate an absolute value of 0. So that means that my vertex is going to occur here. So that's one way of understanding, oh, that's going to be a shift to the left. Seeing what value of x will generate the same y value on the previous graph. And that's going to be absolute value of x plus 1. And then, if we look at f of x plus 1 to which we subtract 3. Now subtracting 3 will decrease the value of 3 for every y coordinate on my curve. So so that means everything here gets shifted down by 3. So this minus 1, 0 will be sent down to minus 1, minus 3, and then I'll have something that looks like this. Yeah, I'm not too sure how it intersects the y-axis. It's actually not too hard to know. If you replace x by 0, you get 1. So it actually intersects at minus 2. So it would look a little bit more like that. And with this V shape. So this is just a sketch, right? And this would be 0 minus 2, because that's what you get by replacing x by 0. And then we could figure out what are the x-intercepts. Okay, so that would be equating this the formula for h to 0. Okay, we're not going to do that. So as you can see here on this graph, they've done what I've done here in 3 steps, but all in the same graph. So they've shifted by 1 to the right and then shifted by 3 down. 1 to the left and then 3 down. So we're going to do another one. So here we're given the square root function and we want to calculate this. In other words, we want to sketch the graph of root of x minus 1 plus 2. Now if we think about this, okay, well that's going to be a shift of 1 unit to the left or right, to the right of the square root function. So if the square root function is, so it goes to 1, 1, and then to 4, 2, something like that, okay. Once again here, this point is pretty important. This is where the square root function starts, 0, 0. So what would I need to replace here x by to get essentially 0 for my y? I would need to have a 0 underneath the square root. So this would need to equate 0. So in other words, x would need to be equal to 1. So this is how Subtracting 1 from x underneath the square root now shifts the graph of the square root 1 unit to the right. So this is y equals square root of x minus 1. This is y equals square root of x. And finally, if we look at square root of x minus 1 to which we add 2, it's going to shift everything up by 2. So my vertex now is going to end up there in 1, 2. And you'll get basically the curve in blue for the graph of square root of x minus 1 plus 2, which is the graph of h. Okay.